sorry, go back to the tools. The profile tool, which opens up this one box in the bottom, right? Line profile duplex is what the image is that has up. So this is your profile tool based on a line or a box, okay? And what I choose to draw that box is up here where the magic wand is. To the right of the magic wand, it says ruler. And then I do the measuring rectangle so I can get a box 60%. So I click on right next to S&R in my toolbar. So I draw a box. I pull it, let off the left click mouse button, grab one side, come on, straighten it up, and then make sure it's 60%. And then it does, it's as long as it's more, it's fine. When we do the automatic tool, it's going to take the whole duplex. And then what I'm doing is I'm just going over each one of these. Oops, I did the wrong one. D1, D2, D3, D4. Now you can see when I go over the line, you see how the black lines show me that it shows me the dip and the valleys. What we're looking for per code is a 20% dip. Anything after the 20% dip that's where you start, for instance. So 1, 2, 3, 4, 5, 6, 7. So I think around 7 or 8 is going to be 20%. So what I'm looking at in the bottom of this box, it says distance, density, not density, film density, density, image density, grayscale, modulation, 25%. So that's still above 25%. So I'm going to go to the next one, which would be D8. Now the modulation is 12. Okay, that's a failure right there. I can't use that one. So I go back to this one, which is 25%. So D1, D2, D3, D4, D5, D6, D7. That is unmod. So this panel is D7 unmodulated or uninterpolated. Per code, we get the next line pair after. So we would actually say this is a D8. This would qualify for D8, which is 160 micron. That's the width. You can kind of see, and this is a visual inspection, so you can see a lot of space between this first line, second line, third line. Everything looks good till you get to about 7. You can still see the space, and then 8. Yeah, it's kind of hard to call 8 here, right? There's no real definitive straight black between the two lines. This is called SRB or BSR, Basic Spatial Resolution, or you might see it as BSR or SRB, Basic Spatial Resolution Duplex Wire Pentameter. We did a manual one. Now I'm going to show you how to do it automatic. Still going to use the exact same line profile, but the software is going to do it for you. Take the contour rectangle up to the right of the S&R. I click on that. I draw a tight box just around the duplex. Image analysis, basic spatial resolution, or RSB. Click that. And then the software automatically did exactly what we did manually. It's telling me 1, 2, 3, 4, 5, 6, 7. Automatically, it got 30%. Manually, we got 25%, but that doesn't matter because the next one was still below 20. So we got the same results manually that we are getting automatic. Up here in the top, it says SRB detector. So this is uninterpolated, 180 microns. Interpolation, which means the next line pair, which was 160. And then in parentheses, this is the angle of the duplex. So the code requires a 3 to 5 angle on the duplex. So 4.4, it disqualifies. This is a good shot, or this is a good qualification. 2 ways to do SRB or basic spatial resolution. You can do it, and you can see in this image, it puts the rectangle measurement tool inside the box. SRB, basic spatial resolution, has to be determined for hardware qualification for an application. For instance, this block right here is an ASME demonstration block. And this would be based on the thickness. Now I know the thickness of this block is 0.62 inches. There's a 2% sensitivity notch right here in the middle. I'm just going to exaggerate a little bit so you can see it. So that notch right there is 2% of the thickness. And then the IQIs, the IQI, there's just different IQIs. I can see that I'm getting image quality with a hole type or wire type. I put 2 holes on here so I can see the 4T, 2T, and 1T. And really what they're looking for is the 2T or however many wires is required for this thickness. So we're seeing 1, 2, 3, 4 wires, roughly 3 wires maybe on your computers, which qualifies this thickness, this technique for whatever this application is. So I could go back and say I've qualified 140 micron panel. I've qualified the 140 micron panel for this thickness, and now I don't have to do that again. It's been qualified. It's that procedure saved. That qualification is done. So you have hardware qualification, software qualification, and technique qualification. All of our tools assist in making those qualifications. And then one other thing on this one is if you wanted to have all of those tools, the profile, the scope, the lookup, the defects list, you could have them all right there. And it's just in tools. So I check the bottom one and it turns on or turns off. So if you check it, then all the tools are right there at your fingertips.